Welcome back to The Explainer. Today we're exploring a truly fascinating technological transformation. So I want you to think for a second about a massive industrial refinery. A complex facility taking crude, unrefined oil and just meticulously turning it into high-octane fuel. Well, today we're looking at the exact same concept, but entirely in the digital realm. We're talking about the synergy of the Internet of Things, or IoT, and big data analytics. Throughout this explainer, we're going to unpack how the raw material of countless connected devices, literally everything from factory temperature gauges and motion sensors to complex global supply chain trackers, how all of that is piped into a digital refinery and transformed into highly valuable, actionable insights.
Let's trace this journey. First, we'll look at the big data synergy, then defining IoT analytics, followed by revealing hidden business patterns, and finally, the merger of industry. Let's get into it.
Section 1. The Big Data Synergy. Section 2. Defining IoT Analytics. To make any sense of the massive, kind of chaotic influx of connected device data we experience today, we first have to understand the organizational solution that actually tames it.
Okay, so let's dive into this foundational process. IoT Big Data Analytics is basically the deliberate, step-by-step examination of vast IoT data to reveal trends, unseen patterns, hidden correlations, and new information. Think of it like passing millions of disorganized, raw data points through a super sophisticated algorithm that separates the crucial signal from the overwhelming noise. We are talking about ingesting petabytes of telemetry, logs, and status updates, and then running them through advanced machine learning models. It's really not just a buzzword. It's a rigorous methodology that cleans, parses, and structures data from thousands of different hardware sources before any actual human insight can even be drawn.
Section 3. Revealing hidden business patterns. First up, the analytics engine acts like a massive digital filter, extracting overarching trends from the constant stream of IoT feeds. When you're analyzing data point after data point over long periods of time, the analytics process smooths out the daily anomalies and shows you the macro direction things are actually heading. For example, imagine an electrical smart grid, right? It has millions of meters reporting usage every few seconds. Now, a single home turning on a high-voltage appliance at 3 in the morning, that's just a meaningless anomaly. But when the analytics engine processes an entire city's data over a month, it extracts true macro-level peak usage trends. And this is a game changer. It allows utility companies to dynamically route power and prevent brownouts based on actual overarching behavior rather than isolated spikes. Next, it illuminates unseen patterns. And honestly, this is where the sheer processing power of big data really proves its worth, identifying sequences that would be completely invisible to the naked human eye. Why does the human eye miss them? Well, because these patterns often involve multivariable sequences happening across completely different time frames. A human looking at a spreadsheet of a million temperature and vibration readings just won't see a thing. But an algorithm? An algorithm can track a micro fluctuation in temperature combined with a really subtle acoustic shift in a turbine arm, spotting a recurring mathematical sequence that happened exactly 3 times prior to past system failures. That unseen pattern instantly becomes a predictive maintenance alert, which can literally save millions in breakdown costs. No way a human catches that, right? And this concept brilliantly illustrates hidden correlations. A correlation is basically a connection between seemingly unrelated data points, showing how one action inherently affects another across a whole system. Big data analytics finds these hidden threads, linking variables that no human engineer would naturally even think to compare. For instance, advanced analytics might reveal that a tiny 2% drop in ambient factory floor humidity strongly correlates with a 5% increase in a specific automated lathe's energy consumption. You wouldn't normally connect the room's moisture to that specific machine's power draw, but the data absolutely proves the cause and effect. This enables highly targeted environmental optimization that saves significant overhead. It's like a giant puzzle coming together. Ultimately, all of this intense processing, finding those sweeping trends, exposing the unseen multivariable patterns, and mapping those hidden correlations, it all distills down into entirely new information. This is high-value knowledge that was previously just locked away within the raw data. To go back to our earlier metaphor, this new information is the high-octane fuel. It's the refined product, the newly generated predictive models and automated decision-making protocols that was previously trapped in the crude ore of basic telemetry data. The data was always there, for sure, but the analytics process essentially forged it into a tool you can actually utilize.
So, what does this all mean? The absolutely crucial point is how this translates into massive real-world value. The ultimate objective here is to manage huge amounts of information that can actually affect businesses. Companies and individuals directly benefit from analyzing these large data sets because they gain the unprecedented power to shift from reactive to proactive operations. Managing this information means your supply chains can automatically self-correct when minor weather delays are detected, or your manufacturing floors can dynamically adjust their output pace based on the real-time availability of raw materials. It fundamentally impacts operational success. It's a total paradigm shift.
Section 4. The merger of industry. Let's break down exactly how this integration happens in the real world. The process arc flows logically through 3 focus areas. Step 1 establishes the core capability, which is integrating big data analytics directly within the IoT framework. This often takes the form of edge computing, where initial data analysis happens right at the device level, ensuring only the most crucial, relevant data is sent to the central servers. Step 2 focuses on the mechanics of the continuous feedback loop, detailing exactly how the vast IoT network feeds that structured stream of data upward to the main analytics engine in real time. And finally, Step 3 is the whole shebang, the merger of industry. Often referred to as Industry 4.0, this is where digital insights become so integrated that they automatically trigger physical industrial operations without human intervention. The digital analytics and the physical machines literally merge into a single, seamless, self-optimizing ecosystem. Which brings us to our conclusion. As IoT constantly feeds big data, is your business ready for the merger of industry? Really think about how your own operations are generating massive amounts of data right now. Are you just collecting raw, unrefined oil, or do you have the digital refinery in place to capture its true value and power your future? Thank you so much for joining me for this explainer, and keep looking for the patterns hidden in the noise.